Hawaiian Eruptions. These eruptions are the least violent and are known for their calm, steady lava flows. The magma is very fluid, allowing it to move easily across the surface without building up pressure. Instead of exploding, the lava pours out in glowing rivers, slowly covering the land. This type of eruption forms wide, gently sloping shield volcanoes over time. A well-known example is Mauna Loa in Hawaii, where repeated eruptions have shaped large parts of the island. While these eruptions rarely cause sudden destruction, they can still damage homes, roads, and farmland as the lava advances. Their slower pace often gives people time to evacuate, which reduces the risk to human life. Hawaiian eruptions matter because they show how volcanic activity can build landscapes gradually while still having a lasting impact on nearby communities and ecosystems. Strombolian eruptions. These eruptions are slightly more active and are marked by regular bursts of lava and gas. Instead of a continuous flow, magma rises in bubbles that burst at the surface, sending glowing fragments into the air. The explosions are usually small but frequent, creating a rhythmic pattern that can continue for long periods. Stromboli volcano in Italy is a classic example, known for its constant activity that has lasted for centuries. Although these eruptions are not extremely powerful, they can still pose risks from falling lava fragments and small ash clouds. People living nearby must remain cautious, especially during periods of increased activity. Strombolian eruptions matter because they demonstrate how gas pressure influences volcanic behavior, and how repeated small explosions can slowly build up volcanic cones over time. Vulcanian eruptions. These eruptions are more explosive and occur when thick magma traps gases beneath the surface. Over time, pressure builds until it is released in a sudden, powerful burst. The result is a short but intense explosion that sends ash, rocks, and gas high into the air. These eruptions often happen in cycles, with periods of quiet followed by sudden blasts. An example can be seen at Sakurajima in Japan, which frequently produces ash plumes that affect nearby cities. Vulcanian eruptions can disrupt daily life, damage infrastructure, and pose health risks due to ash inhalation. Compared to earlier types, they are more dangerous because of their unpredictability and force. They matter because they highlight the role of thicker magma in creating explosive volcanic activity. Plinian eruptions. These eruptions are among the most powerful and dramatic volcanic events. They produce massive columns of ash and gas that rise high into the atmosphere, sometimes reaching the stratosphere. The force of the eruption can spread ash over vast regions, affecting areas far from the volcano itself. A famous example is the eruption of Mount Vesuvius in 79 AD, which buried the cities of Pompeii and Herculaneum. These eruptions can collapse into pyroclastic flows, adding to their destructive potential. They can also impact climate by releasing large amounts of particles into the air. Plinian eruptions matter because they show how a single volcanic event can have widespread and long-lasting effects on both local populations and global systems. Pelean eruptions. These eruptions are extremely dangerous due to the formation of pyroclastic flows, which are fast-moving clouds of hot gas, ash, and debris. Instead of rising into the sky, the material rushes down the sides of the volcano at high speed, destroying everything in its path. The eruption of Mount Pelean in 1902 is a well-known example, where the town of St. Pierre was devastated within minutes. The magma involved is thick, which allows pressure to build before being released suddenly. Pelean eruptions are especially deadly because they offer little time for escape once the flow begins. They matter because they represent one of the most lethal volcanic hazards, demonstrating how quickly conditions can change during an eruption. Phreatic eruptions. These eruptions occur when water comes into contact with hot volcanic rock, turning instantly into steam. The rapid expansion creates an explosion that blasts ash and debris into the air, even without new magma reaching the surface. These events can happen suddenly and often without clear warning signs, making them particularly dangerous. An example is the eruption of Mount Ontake in Japan in 2014, which caught many people off guard. Although they may appear less dramatic than large magma eruptions, phreatic explosions can still cause serious harm. They matter because they highlight the risks present even in seemingly quiet volcanic areas, where hidden heat and water can interact unexpectedly. Phreatomagmatic eruptions. These eruptions happen when magma directly interacts with water, leading to violent explosive reactions. The contact causes the magma to fragment into fine ash, producing powerful blasts and wide ash clouds. These eruptions can create base surges that move rapidly across the ground, spreading destruction over a broad area. The formation of Surtsey Island near Iceland in 1963 is a well-known example of this process. Phreatomagmatic eruptions are more explosive than purely steam-driven events because they involve both heat and magma. They matter because they can reshape landscapes quickly and produce widespread hazards, including ashfall and fast-moving surges. Submarine eruptions. These eruptions occur beneath the ocean surface and are often hidden from view, yet they can be highly powerful. When magma rises underwater, it cools rapidly, forming unique rock structures and sometimes triggering explosive reactions due to pressure differences. In some cases, repeated eruptions can build up enough material to form new islands above the sea. An example includes volcanic activity in the Pacific Ocean that has created new land over time. Submarine eruptions can also disturb marine ecosystems and, in certain conditions, contribute to tsunami formation. They matter because they show that volcanic activity is not limited to land and can significantly shape the ocean floor and coastal regions. The Earth is more powerful than we think. Subscribe for more content like this.